So should I? Okay, so if there are no questions, okay. So yesterday I gave you an assignment also. Any problem in that?
No, sir.
Okay. Okay. So okay. So we will start with our today's exercise in that case. Okay. Let me just share my screen. Uh, okay. So hope you all can see the screen now.
Yes, sir.
Okay. So the topics that we are going to cover today. Not this one. Okay. So these are the topics that any experiments will be covering. We'll see if we get time, we can try something else also. Okay, so first of all, we'll see what is Tinkercad and Arduino. Then we have some basic functions and operators in Arduino Uno that we will try out in the Arduino Uno board. On the Arduino Uno board using this particular platform, and then we will look at all these different sensors and actuators, and we can try to make some systems out of it. Okay, so this would be our agenda for the day. Okay, and okay, so how to basically start with this? So let me just close this. Okay, so obviously Tinkercad, will search on Google. Tinkercad is basically designed by a company called Autodesk. Uh, One second, not Autodesk. Okay, so this is how it looks like. So you can log out here, and if you don't have a profile, it is simple enough to make one. Let me show you where. Like I'll usually go into sign in, but for any newcomer, it will be join. So here you can see educator starts here, students here, and personal accounts here. So this way you can initially categorize which of the class you are working in. Like if you have faculties, like you can go here. Students can click here, and let's say if I'm using it for my personal account, then here. So anyway, we'll go here, and I am an educator. I have permission to moderate student. All these terms will just agree.
So screen
Then
is
you
not visible, sir. Hello, sir.
screen is not visible.
Yeah.
Everyone else also is not able to see my screen.
It is visible to me, sir.
It is visible, sir.
Okay. Okay.
So please
I'll
check
check it. Yeah, sure.
network
Can
at
I
your end.
reconnect, sir?
Okay.
Yeah,
Okay.
please check it, sir. Once the
Okay.
okay, so we'll move on. So here you can just sign in with your email, and it would be taking no time. Like your Gmail, you can use. But anyway, I have an account, so I'll just log in. Okay, so this is the first page that you will see when you open up this particular platform. Now, Tinkercad offers you some more things like some 3D designing simulation also it helps you with. But obviously we are not looking into that part, so we will just go to our circuits. Okay, so this is the circuit. Then we have this 3D design code block lessons. All these things are available here. Okay, so Tinkercad is a free, as you can see, collection of software tools that helps people all over the world think, create, and make. We are the ideal introduction to Autodesk. Autodesk actually is a tool which is used in 3D designing and all. I think the company's name is Adobe, if I'm not wrong. The leader in 3D designing, engineering, and entertainment software. So, for that particular thing, they have created a very small version or free version of the similar tools, which is Tinkercad. Okay, but they have added circuits also here, which will be this. Okay, circuits we have opened. So I will just click on create new. So let me just click on that. Now this is where we will make our circuit, and we have all these components you can see here. Okay, so there are multiple components like ultrasonic sensor is there, PIR, temperature sensor is there, multimeter is there, piezoelectric, then diodes, LEDs. Okay, so all these parameters are there, all these components or sensors and actuators are here. Okay, so you can just look at the library here, components, and a basic all base stratum. We have basic Arduino, circuit assembly, and all. So let us just look at Arduino. We have Arduino with breadboard here, Arduino with already having a blink setup. Okay, so there are some ready-made model available for you here, which you can always just copy paste from here and use it. Okay, but we can also try it. Let me just show you one. If this is, it's a blink. Okay, so what I have to do, I have to just
Nita,
click on, yes, ma'am.
I'm not getting these components.
Uh, Ma'am, you're getting the screen. So
No,
once
sir,
you log in here,
when you go to circuits, the next step,
okay.
circuits.
So once you go to circuit, ma'am, there this is one
Sorry,
place,
no, it's blank screen is coming for me.
blank screen.
Yeah.
One second. Let us show, ma'am.
Okay.
Please show it. We'll see.
Can you see my screen, sir?
Yes, ma'am, we can see. So this hasn't been loaded, ma'am. Just refresh it.
How to refresh it?
Reload. This might be some internet connection issue.
Okay. Mine is not loading.
It will come, ma'am. It will come. You can see now right now it is trying to load in the middle. So might be some internet issue. If
Okay, sir, I'll stop sharing.
no problem. So it will anyway load. So just keep it like this for 5-10 minutes. If it doesn't load, let me know. We'll see you then.
Okay, sir.
So I'll share back my screen now. Okay. Okay. So let me just
I saw.
delete it and I will start again. Okay, so you see under starter here, the basic component, if we see, we have resistance, LED, push buttons, potentiometer, capacitor, slide switch, coin battery, 9-volt battery, then 1.5-volt battery, breadboard small, all these sensors and motors, LEDs are here. Okay, then if we go under all, we have they have categorized like general purpose components like inductor and diode, capacitor, resistance, then input, which would be your potentiometer, push button, slide buttons, and these sensor will act as an input device only. Okay, Then we have output, which would be LEDs, bulbs, neopixel. These things are here. Then your 1 second. Then DC motors are here. You can see micro servo and all this remote and etc. Okay, so this is how okay, so these are the basic all the components. Then under starters, if we see, we have a basic circuit like a battery connected through a resistance to LED, and then a dimmer also based on the potentiometer. Then these are some basic circuits they have made for you to just test. Like if I use this, I have to just single click over it and then drag it here. Okay, I have to do nothing. So in this case, there is no code required because there is no MCU. So the connection is like there is one LED in parallel here to a variable resistance. Okay, so let us just start a simulation and then we'll see how this works. So for that, you see here is one button called start simulation. So if we click over that, you see the LED is started glowing. So if I change the value, it stops. Okay, were you able to see that? This is right now glowing.
Yes. Yes.
So if I rotate it, it will stop. Okay, reason being that we are increasing and decreasing the resistance, so majority of the current is going through this, and hence we are getting this. So we can stop simulation here. So you can just simply delete this part. We don't need it. Okay, then there are some other things also, like what is this one? Let us see. Okay, so this is an RGB LED. Okay, so let me just run it once. If I press this, you see the red LED is glowing. Then here we have blue. Then we have green. So basically, it's a very simple circuit again they have made. So you can try and test this also as per your own need. So this is basically just to let students be comfortable with the tool. Okay, so that they can go and then do other stuff which will include MCU and bit more complex things than a basic resistance and a battery and all. Then we have some basic Arduino circuits already, which we will see in a few minutes. Okay, then we have circuit assembly, again the similar thing. We have move circuit assembly, glow circuit assembly, basically LED circuit is there. Then these are categorized as all. So we have basically everything to just put in a simple embedded system. Okay, so now first question that would come into our mind is where to write our code and where to check our output in case we are using a microcontroller. Like generally we were just using battery along with some LED and we didn't need any codes to be written. So in that case, what we'll do, we'll go here. You see this tab here, which is for code. So if I click over it, you see another window comes up, and this is where we will write our code. Okay, so right now you can see no programmable component in the circuit. So that is why this particular part is disabled. So let us just put some component into it, programmable component. And let me take Arduino Uno, put it here. Okay, so if I open it now, so you see now we this thing is what we can use. Okay, so this we can use this as a block also, like this block programming, which I will not tell you, and I will just show you the normal text part, like normally we do program it. Okay, so this program is basically just blinking LED connected at pin number 3, which is this one, which is an inbuilt LED, high and low every 1 second. Okay, so this code is already written. We'll discuss the code later on. Let us just, you can see that this LED is glowing on and off, on and off. So let me just show you another. Let me just show something else. So I will use this particular LED. Okay, and you see cathode is basically a ground. So let me just connect it to ground. Okay, so it is as simple as this. You can just use these wires like that. Okay, so this is up to you how you're using it. Okay, so now let's say red on pin number 7. So single click here, then drag to the next point, then drag to the next one. So this is how it is. It is very simple to connect circuit here like this. So what I will do, I will just go into code, and now we are using pin number 5, 6, 7 also. So this command anyway, I will show you later in few minutes. Let me just show you how things are working here. So these are 5, 6, and 7. Okay. The code that I will be writing is basically glow one part and then switch it off, then glow another color, and then switch that off also. So this is a simple thing. Now if I start simulation, you see now it is red. So it will glow like in a pattern. Because that is what we are doing here. And in every loop, it will keep on doing same thing. Okay. So let's say if I make some syntax error here, and then if I start simulation, you see it will give some error that there is this expected before delay. Yeah. So you can see the syntax error also, it is checking. Okay, so this is basically how you can work. You can just keep any sensor here, then connect it, name it as per your experiment requirement, and then use it. Okay, so you can zoom in, zoom out. All these things are available for you. Now, if you see is pretty what I can say, that pretty famous platform today, which most of the students are anyway using, if even if these things are not in the curriculum and all. Reason being that it is actually very easy to use, and one of the major problem in any embedded system is the programming language, which is not that easy to learn, but obviously not that difficult. But on student point of view, from students' point of view, it could be a bit difficult. Okay, for us it might take maybe few days to learn it, but for them it might be a bit longer time. Okay, so this platform offers you the programming language which is very easy to understand, and not much commands are there anyway. So it is very simple to use, and then they don't have to be worried about all this RAM, flash, different memories, and then assembly part, and then your linker debugger, because generally in any embedded system there are all these different stages. Like I will be writing code into C, but that my microcontroller doesn't understand C. It will understand 0 and 1 only. So there will be a compiler which will convert it. Then there would be a linker. There would be an assembler and debugger, simulator. All these are different stages. But in this case, they don't have to be bothered about it. It's all covered under one layer of an IDE, which is your Arduino IDE. Okay. So I have that anyway installed. Also, I will show you that on later on. But for these reasons, this is very popular. Now, another thing that make this particular system popular is the price of this. Like this you can buy in like 450 or 500 rupees, very cheap. Then all the sensors that are there available ranges from like 50 60 rupees to 100 200 rupees. There are few sensors which will go around 3 4k, but majority of these sensors are like 100 200 only. Okay. Then we have multiple IO pins also available. Like you can see in this case, we have these are like power pins. These are analog input. Okay, so mind it that these are only input pins. We have 6 input pins, analog inputs. So they cannot be used as output also, but only input. But these analog pin can be used as digital input and output also. That is up to us. Okay. Then we have digital pins 0 to 13, which is 14. So 14 and these 6. So 20 digital IO pins we have total, and out of which 6 can be used as an analog input. Then we have 6 PWM input also. Sorry, output. Like this 3, 5, 6, 9, 10, 11. You can see some sort of sine wave in front of them. Okay, so these are PWM pins. So you can generate PWM using these pins. Okay, so how you can do that I will tell you. There is a special there is a command for this which you can use. Okay, so that I will show you. Then we have serial also, like UART also is there, and TX and RX is this pin number 0 and 1. We have SPI also in this, which is pin number I guess 11, 12, and 13. Okay, so there are many inbuilt serial protocol also that has been given to us. Okay, which we can use in our application. Okay, so this is pretty much it, and why basically this particular platform is very famous. Okay, so now what I'll do, I'll show you some of the commands of this particular which will help us understand it in a better way. So okay, so Arduino, obviously there are multiple type of board. You can see there are Arduino Mini is there, Micro is there, Uno is there, this is the one we are using. The Leonardo, we have Mega, Duo, all these things are there. And now you can select one of these as per your application. Okay, so basically they differ in terms of digital IO. Like in Uno, I said that we have 28 digital IO pins, but in Mega we have 54. Okay, and if you need like in this case we have analog input pins. Okay, if you need analog output, you see all of them are 0 except Duo. So you have 2 output pin also. So if you are looking for some analog output application, then this is your board. Then obviously the working frequency is 84 megahertz. So if you're looking for a fast application, then this is your preference. So you can take a screenshot of this particular slide. This will help you select these one of the board as per your application. Now obviously there are one or two more which is not listed here, but yes, I guess this is just to get an idea. Okay, so you can take the screenshot here. Okay, so now I'll move on. Okay, so this we have seen. Okay, now the commands here are normal, like addition, subtraction, multiplication, modulus are there. Comparison may we have equal to, all this less than equal to, greater than equal to, not equal to, all these things are there. Then we have logical and Boolean operator also, and bitwise operator also. Okay, so what are these? I will just show you in a minute. We'll work on it. One second. Okay, so these are the commands also that has been given here. You can look. Okay. Then, okay, then we have some loops also, like while loop. Basic while loop is there. Do while loop is there. For loop is there. Now we can make infinite loops also using these said loops. Okay. Then we have if else statement there, and then we have some functions that Arduino has, like commands you can say. Like pin mode is a command which will help us. Like I told you that we have pins here. Like we have this digital pins here. These can be used as input also and output also. So we have to define which particular pin is being used as input or output. So for that purpose, we have this particular command, pin mode. I will mention pin number, like pin number 2, and I will mention output or input. Okay. Then if I'm using it as output, I will use a command called digital write, and I will mention again pin number and the value that I want to give, which will be high or low. In case of digital, we have only two values, high or low. But if I'm using it as input, so I will use a command called digital read, and I will just mention the pin number. Okay, so whatever is connected high or low on that pin, it will be read by my command. Okay, now you have to be very careful using these commands, because you see this capital M. Okay, so our Arduino is cap sensitive. So if I'm writing pin and capital pin mode and M is capital, if I write M as small, it won't work. It will give a syntax error. So you have to be very careful in remembering these things. Pin mode, then this W is capital here, then R is capital here, then this R is capital here, this W is capital. Okay, so this you have to keep in mind when you're writing a program. Then we have analog read, as I said that we have analog input pin also. Okay, so these are analog input pins. You can see. So to read any value connected over it, we will have analog read command. Okay, then we have analog write also. Like I told you, we don't have any analog output pins, but we still have analog write also. Now this is the command that we will be using for PW. So and then we have some serial commands. These will help us in debug, and I'll show you that also later on. Okay, so these are some of the commands. Let me just show you some of these operators we will try, and then we will see. Okay, so in this case, obviously we are just trying some operations, so we will not need any other output connected here. So let me just Control A. Okay, so now how you have to start this. So this you can see there would be one loop called void setup, and there would be one loop called void loop, sorry, function, not loop. So basically like this is one of the thing that is also has been changed from our traditional what you can say microcontroller programming. Like here what they have done, they have categorized your command set. Okay, so you will have some commands obviously in your program which you have to run once only. Then there would be commands which you have to run multiple times in your execution. So what they have done, they have categorized them, like whatever you have to run only once, like most of the time these are configuration commands. Like if I want to configure some pin as input or output pin, or if I want to set baud rate, or if I want to just give some welcome message in the initial when I start the program. So these are the commands that are like configurational commands majorly. So that will go under setup. Okay, that I will write here. So commands which will run only once. Okay, but there would be let's say my system is reading temperature from a sensor and then putting comparing it to a value and then accordingly glowing on LED. So this task, like reading from the sensor, comparing it to a value, then glowing the LED, would be repeatedly running. Okay, so that commands which you have to run repeatedly will come here under this loop function. Okay, so this would be having commands which will run continuously. Okay, so this is how they've categorized. So that is what we are also trying to we will also do. Okay, so the commands that we have to give in setup is first serial dot begin. This will basically set up our baud rate. Now generally in this case it might not be required, but when we are working with a real hardware, okay, so baud rate is basically a rate on which our hardware, this microcontroller, will communicate with my laptop, using which I am programming it. Okay, so this is the baud rate that we will set. In real scenario it will be required. Okay, this is the default baud rate anyway, you can set any other value also. Okay, then so one more thing, like if I want to have some global variable, so let me just give my integer x, y, and z. Okay, so under my setup here I will give x equals to 1 and y equals to 2 and z I will just keep as it is. Now under void loop what I will do, I could simply perform like z equals to a plus b, as simple as that. Then obviously I have to see the result. Sorry, not a and b, y and x, y and y. Okay, so in order to see the result, I will use this command, serial dot println. Then I will write z. Okay, then obviously we can give a delay. Now this command is in milliseconds, so 1000 means 1 second. Okay, so what it will do, it will just have the value here. So these x and y will never change because they have been set here once, and in my program I'm not trying to change it. So if I run it now, okay, so the system is running, but in our case, like once we are running the hardware in real life, we can open the serial monitor in my Arduino IDE, or what we can do, we can just use any software like putty and read the data it is sending on the serial. Okay, but we don't have that here. So here we have the serial monitor here inbuilt also. So this is again a simulation only. You can see that it is sending 3 value only. Okay, so this is clear it, you see 3 every second it will keep on sending 3. Okay, so that is what it is doing, and you can even see it in the waveforms sort of wave. So it is constant at 3. Okay, so now we can easily do multiplication, division, and everything. So let us just look at some bitwise operations like AND. Okay, I'll share what it is. Yes, sorry. Okay, first I need to stop it. Okay, so bitwise and like if I say now 1 can be written as 001 and 2 can be written as 0010. Okay, now if I do bitwise and like bitwise means like every bit separately. So if I do AND operation on this, like 1 and 0 would be 0, then 1 and 0 would be 0, 0, 0 would be 0. So the result should be 0 here. Result should be 0, 0, 0, which is again 0 only. So if I run this now, what should we get? 0. You can see we are getting 0 now. Okay, so this was our bitwise AND operation. Like now I can add OR also. This is bitwise OR. Just run it. Now OR what is happening, like 1 and 0 would be 1, 0 and 1 would be 1, 0, 0 would be 0. So the result is 0, 1, 1, which is 3. That is what we are getting. Okay, so let us just make it, let's say 4. Now the 4 would be 1, 0, 0. In this case we will have 6. You can see this is bitwise OR operation. Okay, so similarly we have some other commands also here. You can see bitwise XOR is there, NOT is there, shift left, shift right is there. That I'll show you. Like if I say y is 1, which means it is 0, 0, 1. Okay, so if I use z equals to y, this command 1. This command means that shift the bits 1 towards left. Shift left, because you see the arrows are pointing on left side. So if I shift this once here, so it will become 0, 1, 0, which would be 2. So now my z should be 2. You see it is coming as 2 now. Okay, so if I, let's say, make it 2, let's say make it shift towards left twice, which means 1, 0, 0, which will make it 4. So now we will get 4. You see. Okay, so similarly we can make it shift towards right also. If let's say I take x and you see this particular arrow is pointing towards right, so that means shift towards right. Okay, so x is right now 4, which is 1, 0, 0. If I make it shift 2 times towards right, it will become 0, 0, 1, which will be 1 only. Okay, so similarly we can make it shift towards right 1. That will make it 4, sorry, 2. Okay, so this is what we were doing, and instead of just giving a direct number, we can actually use another integer. Like x is shifted towards right y times. Now y I know is 1, so it would be shifted towards right 1 time, which will make it again 2. Okay, so you see again 2 is what we are getting. So these are our bitwise operations, which will come in handy when you are doing some sort of processing on the data you have received. Okay, so right now we might not be doing that much, but again, yes, in future you might need it. So any doubt up till now? Are there
Sir,
any
can
doubts?
we use this 8-bit register, sir? XYZ as 8-bit data?
Yes, ma'am, we can. Like if you want, let's say 10. 10 would be 8-bit, na? Yeah. That also can be done. So
This will be 4 bits, sir. 1010.
oh yes, yeah, 4-bit. Okay. Yeah. So any that you can use. There's no such
Okay.
issue like that. Okay. So that is possible. That shifting part you can do, and I am not very sure if there are any sort of experiment in syllabus for bitwise operations, but yes, they might come in handy for some of the project students are doing.
Hmm.
Okay,
So Arduino can work on up to 8-bit or 16-bit also, sir.
Arduino we have various boards, na, like I
Yes.
was showing you. Like this one is generally Arduino is 8-bit only. Uh, okay, so I'll check if this one is 16-bit or what, because I think this one this Duo is a 16-bit 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 board. And let me just check. 16. So I guess no, not this. Uh, I guess that Arduino Mega is also 16-bit. Arduino Mega and Duo. That anyway we have to check the specification for that. So that can be done. Okay, so but we'll be working on Uno only. So we'll stick to 8-bit data here only.
Right.
Okay, so this was the basic introduction of the tool and the Arduino Uno and the basic commands. Okay, so now we can look at some particular things like operations and functions we have seen. So I'll just show you some basic experiments. Like we'll not need these variables now. So let me just delete it. So now what I will do, I will do some sort of processing like digital, not digital. So initially we need to mention which pin we are using as input or output. Okay, this is what I will, sorry. Syntax for that is, if let's say I'm using pin number 4, so pin number 4 is caps में output. So you have to be sure that this all has to be in caps, not in small. So it won't recognize if you write in small. And pin number 6, let's say is input. Okay, so if let's say I just write input normally, if I simulate now code, you see it is giving me the error. Input was not declared in that sense. So anyway, this we have to change capital. Okay, so pin number 4 is our output. Okay, so this will generate an output, and then pin number 6 is our input. So what I will do, I will just connect it. So I will just short these two pins. So which means whatever I am giving output on pin number 4 will come on pin number 6. Okay. So now on the programming part, I obviously forgot. I will initiate one variable, one boolean variable x. Then what I will do, I will digital write on pin number 4. Let's say hi. Then what I will do, x is equals to digital read on pin number 6. Okay, so I will write hi on pin number 4, which will be transferred to pin number 6, and that is what I will be reading back. Now, what I will do, I will use some if command. If x equals to hi, then what I have to do, then serial dot print ln hi. Okay, or maybe what we can do, we can use not operation here. Like this particular command is a not operation which will convert it. So basically, if I'm giving high here, we'll get low here. So that is what we will get. So else maybe we'll write serial dot print ln low. So this is what we are trying to achieve. Now what I will do, I will just give some delay of 1000. Let's say give it 2000, which will be 2 seconds. So now what I will do, afterwards, digital write. Again, I will write on pin number 4, and now I will write X. Okay, so let me just delete this and put it here. Initially, I made pin number 4 high. Okay, so which will be transferred here. Then if I printed, if it is high, then print high. If it is low, print low. Then what I'm doing, I'm just writing whatever is the X value. Like if it was high initially, then it would become low when we read here, because we are using a not operation here. So now low will be written over here. Then again we will read low, and then high will be written here. So it will keep on toggling high, low, high, low, high, low. Okay. So let us just simulate. Okay, there is some error. Boolean does not name a type.
So typo error is there. B
What?
double L E A N. So first line, sir.
Okay. LE. Okay, I made some spelling
L
mistake.
E N. Yes.
Okay. Still some errors here. Okay, some hyphen is missing. Where? Okay, here. Now it is running. Yes. If I open, okay, it is just writing high. Why it is writing high only? Did I made some mistake? Can you check what mistake I have made? I have a code which should be writing high, low, but no, it's not doing that. Okay, just to show you once, the command for inversion is this only. Okay, so the command that we have used should be working. What is the problem here? Where we are just getting high. Can anyone tell?
So eighth line may be digital write 4, comma X, or this is high.
Wait, which line? One? Eighth line.
8th and 19th lines are this 4, comma high, or in 19th 4, comma X. Maybe some error in this.
No, ma'am. Basically, you see in the serial setup, what we have done here, we initially gave our baud rate, then we defined pin number 4 and 6 as output and input. Okay. So then
So in
what we did?
14th line, so 14th line after equal sign, maybe one extra enter has back.
No,
Something is missing.
that's okay. If I do this now, will it work? Let us just see. No, we're still getting high only. Now basically here we have given the initial high value on pin number 4. Okay, then what we are doing, we are reading pin number 6 because this particular value has been transferred to pin number 6. So it should be high. Now here we have inverted it, which means it should be low now. Yes.
Yes.
So if it is low here, then it should execute this. And then if it is low here, it should send low value to 4. Then again we will read low, make it high, and then serial print this. So it should be high. So it will keep on toggling between high, low, high, low. Okay, so this is basically a situation where things are not working properly. So what we can do, we can just try to debug it. Serial print ln. So I will just print the x value here. So in order to check if it is getting changed or not. So I want to see if that part is working or not. Okay. So this is what we have done. So you see here that it is reading 1 and 0, not high or low. High and low it is not reading, it is reading 1 and 0. So that is what mistake we have done. So let us just, if x equals to 1, then high, else it would be this. Okay, and oops. And this command also we can delete from here, and we can put something here. Digital write. So like in this case, if it is 1, if x is 1, then what we have to do, we have to make it low. So we will write just low here, and in this case it would be already low, we need to write high here. So this command I will give an if else statement. So let us just run. Okay, what is missing? High was not declared. Okay, sorry. You see, it has to be capital. You see, now you're getting 0 and 1 also. Yeah. Okay, but we're missing still missing something, because this is only high that we're getting. It should be low also sometime. So initially it was high, that is what we read. Okay, then let me just stop the execution once. Comment this statement. So in general, if you want to just comment some statement, that means if you want some statement not to execute, then you can just use this particular command here, which will comment this line, and this command will not, this line will not be executed now. Okay, so we read high, made it low. Okay, so this should come here, then made it high again. Okay, so it will keep on running in this loop only. Okay, so that is our logical error. So if it is high here, so this we will not need now. And now it is fine. Okay, so now you see we are getting high, low, high, low. Any doubts?
No, sir.
Okay, so this was a basic program which we can use. We just simply shorted this particular thing. So now in next session we can try to add some sensors and actuator here, and accordingly we will write some program here to understand them. Okay. So if there are no doubts, we can stop for this session, and then we will start back at 12 again.
Sure, sir.
Okay. Neha, ma'am, maybe you can share the attendance comment. Okay, what is shared?
Neha ma'am has shared, sir.
Yeah.
Sure, ma'am, sure.
Uh,
I didn't check that.
Participants, the attendance link is shared in the chat box. Answer will be connecting again at 12 now.
Yes, ma'am. 12 we
Hello,
will start
Devendra.
back. Yes, ma'am. 12 we will start.
Yeah.
Devendra,
Yeah. Okay, fine. Sorry, ma'am.
Devendra sir.
Yes, ma'am.
Again, it is not loading, sir. The same thing
Okay.
is showing.
Just show us the screen once.
Okay. Can you see my screen, sir?
Still not loading.
No,
That
sir.
might be some error with your end. Maybe you try it in another browser once.
Okay, I tried, sir.
Ma'am, you have made the account right now or what?
Previously, sir.
You have this accounts from last quite some time.
Yeah.
And you have used it earlier? Was it
Yes,
working
sir.
earlier?
Yes, yes, sir.
Was it working? So just go back once. Open this any of this previous circuit, like the first one here that you see, Arduino.
This one, sir.
Yeah, yeah. Tinker this. Tinker this, yes.
So
It
actually, it is the
might,
problem. Many time it is. I think our system is slow. That is why this type of problem will come.
system could be slow. There could be internet issue. There could be some issue from internet server also.
The
There
part
could be
being some
multiple issues
experiment,
that happen.
being some simple experiment like diode characteristic. Previously I used this Tinkercad,
Okay.
but I found that whenever I am using my laptop, I find it much
Okay.
difficulties. So
Okay.
whenever we are working in college, institute, so that may not be find a problem because of bandwidth, I think.
I guess yes. The bandwidth is required for this. That is it.
Because for loading itself, it will take some time. Once it loaded, then it will we will work it. No problem.
Okay. Okay. So that might be the problem. So anyway,
Yes,
we'll
sir.
yeah. So that could be the issue that we have here.
But usually what I will do is, usually once it is started, whatever be the component we required, I will take it and replace it. Then after that,
Okay.
if we have no net, then no problem. For the existing component, we can do some work.
Okay. Okay. Well, that might be the problem, sir.
That's what I will do.
Yes. 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 Okay. So anyway, we'll see, ma'am. It will load.
We will join again at 12, sir. Sir. Sir, Devendra, sir. Madam. Madam, I think the recording is continuously going on. I think we can stop. Recording is.
Yes. Okay.
This is the break time. I think recording is going on. You can.